slept well, or did you enjoy walking around campus? Yes. Okay. I'm just stay at my room, and I work so many because now I'm the head of the department in a Japanese university, and I have a lot of tasks to do in the room. So finally, I could not go out yet. But okay, so today I only have 1 hour, okay, to explain the ITS in Japan and Tokyo. And today's topic, I already started yesterday, the last slide, on the data collection, okay, technologies, okay, data collection management, okay. And in the beginning, I explained the typical way of data collections, including the conventional ones, like questionnaire survey or manual counting or a video surveillance system or automatic traffic counter and GPS and others. Okay, and of course recently GPS, okay, GPS information might be the very powerful tool or data set for transport planning and management. Of course, also in Japan, we have various kind of GPS data set, okay, and some of them have been already applied, the transport planning and management. And this morning, I will explain what is happening in Japan in this field. Okay. And some of the data set are collected and provided by the public sectors, like government, national government. Okay. And some of the data set are collected privately. Okay. And this kind of data we should buy to pay a lot of money to get them and analyze something. Okay. And starting today, okay, I start from the public effort by for the GPS dataset. Okay, named this ETC 2.0. Okay, and again, what is ETC? ETC is electronic toll collection. The main role of ETC is to collect the toll. Okay, and the vehicle has some equipment, onboard unit for transacting the money. Okay, and when the vehicle reach some toll booth, toll gate, or some spot for communicating, the toll automatically transacted. Okay, and for example, in your case, so 2 days before, Sunday, I moved from Kolkata to Kharagpur, and my driver used expressway link. Maybe he paid twice or 3 times to reach to Kharagpur. Okay, and I missed to understand the situation well because I was very sleepy and I was saved. But I remember, of course, the driver passed the conventional toll booth and he stopped before the payment point and take his money and give to the conductors. Okay, and ask to open the gate. Okay, so of course in Japan until year 2000, there is no such an electronic payment system. Until year 2000, all drivers should stop at toll booths and pay the money. Or sometimes we can use some kind of prepaid card, okay, and give it to the conductor to pay the money. Okay, but I will explain maybe Thursday. So we start the ETC implementation maybe year 2000 or 2001. Okay, and after that, currently the percentage of the vehicle equipping ETC unit reach 95% on the expressway. Some of the drivers never equip ETC, and such kind of drivers should stop, okay, at the toll booth and pay the money directly to the conductors. Okay, such kind of action is still same, still same. I understand there are some reason why the driver never equip ETC, but I never mentioned here. Okay, some kind of very dark reason. Okay, dark reason. So some of them they cannot have some credit card because ETC system is completely linked to the credit card, and those who cannot have a credit card cannot use ETC. But currently we have maybe I will explain tomorrow. Okay, in the road pricing issues, using ETC, we can enjoy the cheaper toll, okay, rather than paying directly the money. So there are some kind of some inequality happen. But national government has some currently very strong intention to penetrate this system to all of the vehicles. Okay. The reason is not for the toll collection, but for this data collection. Okay, and Prof. Okay, check anytime, all time, frequently their location. Okay, their location. Okay, and inside the vehicle, so we have onboard unit. Okay, onboard unit. Okay, and this onboard unit, okay, this store the position data. Okay. Okay. So time, latitude, longitude, okay, speed, okay, can be recorded, okay, stored in this onboard unit, and every 200 meters. Every 200 meters. Okay. So frankly speaking, not so frequent. Because this system was proposed more than 10 years before. Okay, considering the ability of the communication, we decided not so frequent, but using for some traffic management. I think we need, for example, if the vehicle speed is 72 km per hour, maybe 10 seconds, okay, every 10 seconds, we can get the data. This was maximum effort in 10 years or 15 years before. If we develop this system currently, situation might be dramatically changed. Maybe every 10 meters or every 1 second. In some condition, every 0.1 second. But it depends on the capacity, okay, capacity of the data transaction. Okay. And second type of data, maneuver data. Okay, maneuver data. Okay, to monitor the acceleration. Okay, front and back, okay, acceleration. Yaw rate are recorded, okay, to identify the dangerous situation, mostly. Okay. So position data, all position data can be stored, but this maneuver data to save the capacity, in the case this unit detected the larger acceleration, okay, can be stopped. Okay. There are some threshold. Maybe I remember more than だったかな 0.3G. Okay. Maybe hard braking or sudden start, this kind. Okay. Observed. And problem I will explain later, due to some limitation of the capacity of the data stock. Okay. Maybe only 80 kilometers data can be stored. 80 kilometers. Okay. If this vehicle ran more than 80 kilometers without passing under this antenna, data was disappeared. Okay. All data was disappeared. Okay. Overwriting. Okay. Overwriting. The point is we should set this antenna everywhere. Okay. Not to miss the data. But as you easily imagine, it costs too much. Okay. Could you guess how much is it? I just asked the government. Okay. Could you guess how much is it? In US dollars. そうかな。I heard that 違うな。なんだっけ。500,000 US dollars. 合ってる？Very expensive. 500,000 US dollars for one antenna, setting one antenna. Not only this, but for some construction cost of this kind. Then currently, this antenna has been installed mostly in expressway link. Expressway link. Okay, this causes a lot of problems. Okay, and recently, to overcome this problem, because due to the cost, so expressway company can set up this. But for regional government, they cannot invest too much. Okay. Then our current effort is to develop cheaper antenna. Okay. Very simple one. Okay. Can be set everywhere. Okay. But it's still the undergoing project. I heard that currently we only have 30 set just for the experiment. Okay. Okay. And including ETC 1.0 plus 2.0, so maybe around half of the car already equipped this. Okay. Of course, not all vehicles use expressway, then those who frequently use the expressway already have equipped the ETC unit, ETC or ETC 2.0. And the share of ETC 2.0, quite new one, is just 10% of the total ETC users. Okay. We still should wait the highest share by changing the cars. Okay. When the driver change the car to buy new one, they may equip this. Okay. Okay. And this data can be sent to the server. Okay. And through the intranet, not the internet. Okay. Intranet, the load administration office can utilize those data. Okay. This is the current effort by the national government on the big data in transport planning and management. Okay. ここにいいのかな? ん?
Use the pen to
I use
click
the pen.
on this one. Then click on here and then change it.
あ、これそうか、全部消さなきゃいけないのか。delete。delete all とかあるのかな。
Clear this one.
Okay, yes. Okay, now I already explained briefly the situation of this data collection system based on ETC 2.0. Okay. Then blue dot point is the location of antenna I mentioned. Okay, very expensive antennas, mostly on the expressway network. Okay. And around every 10 to 20, 15 kilometers on the expressway link. Okay. And there are rest areas alongside the road, expressway. SA means service area and the parking areas. Okay. Or national government introduced a roadside station, okay, named Michinoeki in Japanese. Okay. Roadside station for providing the rest for the drivers, okay, alongside trunk road. Okay. And this roadside station also equip this antenna. Okay. And currently, there are hard discussion between the police agency and Ministry of Land Infrastructure, Transport and Tourism. We call this as MLIT. Okay, MLIT. This is road ministry. Okay, okay. And hard discussion between the police agency and MLIT, because in Japan, police agency have a right to manage the traffic. Then, frankly speaking, police agency never want to accept this kind of management devices developed by the other organization. Okay, this is reality. So, for us, we'd like to introduce this system all over Japan, not only for the expressway link, but for the national highways or principal provincial road. But currently, we still waiting for the final decision by the police agencies for their approval. Okay. Of course, recently police agency have been changed their mind and partially accept this kind of equipment. But it takes a long time for the discussion to get permission to set. Okay. For me, nonsense. Okay. And I already explained the data is override problems. Okay, 80 kilometers. So, and our ETC system, okay, consists of two different parts. Okay, onboard unit. Okay, unit plus card. Okay. This unit is for car, vehicle, and this card is for individual. Okay. And this card is not credit card, but linked to the credit card payment. Okay. Payment. If we never insert this card, we cannot pay the toll. Okay. And for example, my case, okay, of course I have a car, and maybe I will change the ETC unit from 1 to 2, maybe within 2 years, because I will change the car. Okay, this might be the final car for me. next might be sharing mobility. Okay. Okay, but at the time I changed to the ETC 2.0, but I only use maybe less than 10 times annually for the expressway link. I'm so busy. But I drive, for example, I sometimes commute to the university by car. Okay. Maybe distance might be 30 kilometers. Okay, going, and additional 30 kilometers going back to home. But one commuting activities, I get 60 kilometers. Okay. My case, most of the data will be overridden. Okay. A very bad situation. Okay. Then, if only one spot will be installed in my travel path, my case, almost no problem. Okay. So to utilize this system, our efforts should be mostly paid for how much we can introduce the antenna to the non-expressway links. But of course, we need to develop the cheaper antenna. Okay. This is the most challenging action currently in our government. Okay, and not only the government, public, but for the private, we already have a lot of effort. Okay. When we set big data in Japan, it's almost equal to these big data. Okay. Okay. And okay, so ETC is already explained. Okay, ETC 2.0, explained. And for example, this. Okay. These players are telecommunication company. Telecommunication, this. Okay. NTT Docomo, maybe once they enter into the Indian market, I think. With Tata, already quit, I think. Okay. So NTT Docomo, okay. This is the largest telecommunication company in Japan. Okay. Maybe share might be around 30%. 30%. And they always check the location by the not by GPS but for the communication action to the some spot. Then they roughly understand the location of the users. Okay. Using this technique, they can roughly estimate how many users locate in some areas. Okay. And Docomo has maybe 30% share, and if they multiply 3 point something, this can be regarded as a Japanese population. Okay. Japanese population. And not only Japanese, but for the foreign tourists or foreign people have this, but they are, for example, your case, you bring this and use this in Japan. Docomo can detect your location through the roaming. So using this technique, they can understand the location of the foreign people, okay, foreign travelers. This kind of data is a very powerful tool for the tourism promotion, marketing, or and they provide every 1 hour, okay, mesh-based population. And mesh size is the minimum case. Around 100 meter mesh, they can provide. How many people stay in this mesh hourly? So this kind of data might be very powerful data source for the OD estimation. Okay. Original destination. Before arriving this kind of technologies, we only ask the individual, where do you start and where do you go? But currently, using this kind of technique, we roughly understand the dynamic OD table. This is quite exciting for us. But frankly speaking, very expensive. They completely understand their potential. For example, I have data in my PC. This I bought this more than maybe very small data. We should pay around more than $10,000. Few days, few zones. Very expensive. And a group is the company operated by the SoftBank. SoftBank is the third largest mobile telecommunication company in Japan. Okay. And they also get the location data through the communication, but they also get the GPS data through the application, and they mix with the population data and GPS data obtained by the GPS data. So they can provide route information or some from where to where. Okay. And they also have 逆だ。Okay, the same. Okay, 100 major mesh. And some this Navitime is the one of the biggest information travelers information provision company in Japan. Okay, travelers information, okay. And they also get the location data through the application. Also, the car navigation service. Car navigation service. Okay. And inbound GPS, this is for the foreign visitors. Okay. Ask foreign visitors to install the route search application, route search application inside the Japan for the public transport. Okay. And once they install and start using, data automatically obtained. Okay. And these two data sets, theoretically, or if we hope, they can provide us every 1 second position data. Every 1 second. But for us, it's very difficult to manage, so we always ask that every one minute might be okay. Okay. This and this, I have both, and now in my PC. Very dangerous situation. Okay, PC. Okay, and interesting data set is this. So this Navitime company also stock the route search result. Okay. If you normally use the route search, for example, in Google Map, you enter origin and destination and which route and what time. They can stock these data. Okay. And if they can find the better way to deal with this kind of data, we can utilize to the traveler forecast, travel demand forecast, okay, in future. So one of their trial is to manage the heavy traffic congestion before and after the big event like sport or concert or this kind. So these maybe all of these services just started within these 5 years. 5 years. Commercially started 5 years. Then using those kind of big data set combined with the conventional travel survey method, currently we have plenty of data set for the traffic management. Okay, this is example. Okay. Example conducted by my student using zonal population data by the entity Docomo. Okay. For example, this time, so this Mount Takao is the very famous tourist destination in the world because this has 3 stars in Michelin. So many foreign visitors, because this is just maybe 40 kilometers from Tokyo city center, and the foot of the mountains, there are railway services from the Tokyo city center, very easy access for the not only for Japanese but for the foreign visitors. Then annually, this mountain accept 3 million people. Maybe this is the largest in the world in the mountain area. And in the beginning of April, we can enjoy the cherry blossom, very beautiful one. Okay. Only 2 weeks. And in autumn, a red leaf or yellow leaf season come for 2 weeks or 3 weeks. And during those 2 peaks, they are suffering from very heavy traffic congestion problem. Even though this area had a very good railway system, but some of them want to come by car. Okay, and try to find the car parking, but it's very difficult to find because the land is so limited for the car parking. And we set up the research project to deal with this kind of problem. And but the first problem is we don't understand from where the travelers come. Okay. Then I use this zonal population data provided by entity Docomo to estimate their origin point. So they check the location annually, and they can guess the residence. Okay, the residence. For the security reason, the privacy reason, this data is not linked to the contract data. Okay. Then for them, they cannot use address data. Okay. Then they should estimate their address, home address. Then, but if this device is, for example, here, for example, here. So if this device is detected around 250 days at night time, these areas, so this can be residential area. Okay. Okay. Using this kind of algorithm, we can roughly estimate the residential place. Okay. Then, of course, this triangle is Mount Fuji, and this mountain attracts more people from the adjacent areas, but some of them come from very far. Okay. Maybe, for example, this. Very far. And right side, not so important this time, but farther area, mostly they come to enjoy the red leaf season. Okay, red leaf season. So anyway, using this kind of data, we can easily understand the OD table without asking anything to the visitors. Okay, and this is another example using this kind of data set to understand the travelers' behaviors. Okay, this case using the GPS data. Okay. Okay, so this is animation. Okay, so 違うわ。Before, sorry. Okay, this is 羽田. Okay, Haneda Airport. Okay, the one of the biggest airport in Japan. Okay, near Tokyo, and we have Narita. This is the main airport for the international demand. But 10 years before, we finally opened this for the international flight. Then, currently, around 30 to 40% of the foreign travelers to Tokyo use Haneda. Okay, and this analysis basing some research project on the how do we activate the tourism promotion near the airport. Okay, near airport. Okay. And our interest is, for example, those who use the night flight. Okay, night flight. Maybe around. In the case, if the travelers have evening flight or night flight departing from Haneda, but they should check out the hotel. Maybe in the case Japan very early, so 11 or 10 a.m. they should quit from the hotel. So they should do something for waiting their flight. And our assumption is provide some better tourism courses for them near the airport. Some of them may come and enjoy and consume something, and this can be linked to the regional economic development. Currently, the most of the travelers may have a time some tourism centers in Tokyo, like Asakusa. This is very famous places for the foreign tourists in Tokyo. Okay. Or Akihabara for IT cities, or Ginza, the conventional commercial centers in Tokyo, or Shinjuku is the hub of the hotels for the foreign tourists of this kind. So very few will come this area. Okay. Then, but it's very difficult to understand where the foreign people are. Okay. Then, in this project, I try to use the GPS position data as provided in Navitime. Okay. Then, we get some plenty of data, and we pick up the last day data, okay, by the tourists. Those who depart from Haneda Airport, and we check precisely where they locate on the day. Then,難しいな。
Choose the pencil.
Pointer, yeah. And now click it.
If you want to write, then choose the pencil.
Okay, don't need. Time is limited. So time goes by. From 2 to 3 p.m. they try to start going to Haneda. But of course, easily understand, they directly go from those centers to the airport. Okay. Then at this moment, we understand the difficulty in providing the tourism courses for them, but checking carefully their behavior, maybe we can do something. But this kind of analysis, 10 years before, it was very difficult, impossible. So situation might be dramatically changed within these 10 years. So I believe these kind of data set may change dramatically the method for the traffic management or transport demand forecast, travel demand forecast, and the transport planning and management. Okay, and I will try to summarize with 10 minutes. Okay, and another way to get the data is this kind, driving simulator. Okay. So do you have this kind of facility in this university? No?
Yeah.
Okay. Of course, in Japan, maybe less than 10 universities may have this kind of, because very expensive. 10 years before, I participated in some research project using this outside the university. Outside the university. Okay. And this kind. Maybe this system, maybe I think already they paid to develop this kind of system more than $5 million US. 5 million US dollars, I think. Okay, because the drivers ride on this car, and they can drive. Okay, in some kind of scenario. Okay, and there are 6-axis motion. I said that we can simulate any curves or any gradient or hard braking, certain action. So we can reflect any kind of driving behavior in this system. Okay. So using this kind of system, so we can analyze to assess the impact of the new services. Because in the field, it's very difficult to do this. in the field. Then before that, we check the performance of the new ITS services using this kind of driving simulator. Okay. That my experience in the 10 years before was this kind. So Metropolitan Expressway, okay, I explained yesterday. Okay. So there are a lot of interchanges like this. So after merging, arriving at the merging point, the merging lane distance is very short. And the driver should quickly change the lane to enter into the through traffic. And many of the drivers in this network get accustomed with driving in such kind of very severe traffic conditions. But some of them are very, how to say, not skillful, and it's very difficult to do the proper movement or maneuver. And our idea is to provide the information of the car on the main traffic and facilitate the drivers, merging drivers, to do the proper action. Okay. For example, this case, if right side, like a drivers look to the right side, and there is a red light, or there is a car behind the wall. So this driver tried to set his position to the black areas. In this case, if he keep this location, he can automatically merge into the. Okay. But some cases just provide information. Car is coming. Okay, car is coming. But not provide the precise location. Okay. And we checked two different systems. One is in-vehicle unit. The other one is just variable message sign only. Okay. And using the driving simulators, we can get so detailed information. And we always record their actions where they look. Okay. Then combining these data, we can mostly evaluate the performance of those kind of system. And maybe you completely believe that this cannot be applied in the real field. So I think this kind of technology might be regarded as one of some ITS, mostly for the traffic safety issues. Okay, later maybe you can get this slide, and if you are interested, please check later. So I just input the one research using the big data. This is a quite different type. So share by, okay, share by. In the case of London have so nice share bike services in cities. Lot of station, and station like this. Currently, the operators has been changed from Berkeley to Santander. So currently, so this is not blue.
Okay.
but red. Red. Okay. Sponsor change. Okay, sponsor change. And this system, if we paid £2, we can use this system one day. In the case we borrow the bicycle and return within 30 minutes. 30 minutes. Then, but the current company, Santander, never provide us a data, but Barclays kindly provide us the data, user data, okay, this kind, like this. Like this, like this. So from where to where, and when they borrow, and when they return. But of course, this bicycle never equipped GPS, so it's very difficult to understand the location during the use. And our challenge is only this big OD data. We estimate how do they use this. Okay. Mostly, we'd like to extract that use for tourism. Tourism. Okay. In the case if the borrowing point and returning point are very close, but it takes longer time, this can be used for the tourism purposes. So checking the distance and time, we can automatically distinguish the trip purpose, this kind of system. So frankly speaking, it was very difficult. It was very difficult. But currently, this kind of share mobility services, some of the operators kindly provide us this kind of big OD data. So using this kind, maybe we can understand some future of the travel demand, and some of them can be utilized for transport planning and management. Okay, so time has come. Then I have additional slide, but later you can check. And if you have questions, please ask us through the email. Later. And currently, I have some time for discussions, yeah. if you have.
You can also take 10 or 15 minutes more after the break if you want to.
Okay.
We'll have a 10-minute break and we'll come back.
Yes. Okay, come back. And maybe next, you will do something. Okay, yes, okay.
Think about it.
Okay.
So you guys can have some tea and come back. And we'll come back, we'll meet in 15 minutes. Okay?
Yes.
And information about ITS and its applications in transport, where we have already looked at how these devices that were originally used to collect electronic toll collection is now also being used as probe devices, which can be used to detect your vehicle, detect the speed, and hence can be used to develop origin destination matrices, which can help you in your transportation planning and management activities. So now, building upon that, I just want to give you some more applications of IT in transport, and then kind of expose you to one interesting concept which has been developed in the United States, which allows you to build such a system. So this will almost for a while convert you into a systems engineer or an electronics engineer, where you are actually building the system and not just using the system. So most of our purpose in transportation is to apply the IT systems for our use. So we are not interested in how the mechanic, how the electronics inside the system is working, or how the hardware, what hardware is, what software is, how is the communication happening between the roadside unit versus the in-vehicle unit. So, we are not most of the times worried about it. But this is an interesting field in ITS which many of the transport engineers are getting into, where they are saying that we know what is our requirement, and if we also understand how these devices work, then we can build a good system. So, this is like you are an engineer wanting to become a banking person, getting a job in banking, but you have to have some financial background to it. You cannot leave it to somebody else who would do banking. So, you are also learning a little bit of banking. So, in this case you are also learning a little bit of electronics, systems engineering, and understanding how to develop this system. Okay. So, I will just we will expose you to that system, and in the afternoon there will be a tutorial on how to develop using examples of how to develop this system. There is a software also which will tell you to use it on yourself by yourself. So, kindly bring your laptops. I think most of you have it. For the afternoon it will be required. Okay, so you already know about this. There are a lot of cell phone users in the world, and all of these cell phone users are potential data points for us. A lot of cellular networks, cellular providing networks. If you see the evolution, you can see that in the early 1960s it started in the US, and now maybe from 2010 onwards or just before 2010, ITS has started in India as well. So, when we look at some technologies that are prevalent today, the first thing you can group them into saying automatic vehicle monitoring. So, what is automatic vehicle monitoring? These are some devices that are inbuilt in your vehicle, which allows you to not only transmit the location, but also diagnostics about the vehicle can be transmitted to the operations center, right? How good the vehicle is, when is the next. So, nowadays if you have a modern car, your car dealership can automatically call you saying that we are noticing that your car has run 8,000 kilometers, your next maintenance is due in next 1,000 kilometers. So, how are they knowing all that? Because they have information from your car, from your dashboard to a management control center where they are getting all this information. Okay. So, everything is in the driver's console in the vehicle unit. Automatic vehicle location is very one of the most prevalent uses of AVL is in public transportation. So, one of the drawbacks that yesterday we were pointing out was it never comes on time, the schedule, it never maintains schedule. So, these AVL devices are mounted on buses, which allows you to track where the buses are and allows you to know that whether they are running on schedule or not. If they are not running on schedule, the driver is communicated saying that you have to make up 5 minutes, you have to make up 2 minutes, you have to make up 1 minute, and so on and so forth, and that same information can be displayed on the bus stands as well, that this bus of this route is running 5 minutes late, 2 minutes late. So, this AVL is very much in use. Even in India, many of the buses have AVL systems attached to them. Okay. So, that is one. The next is vehicle system monitoring. Oops. Passenger boarding and loading data. So, these are systems that allow you to, these are systems usually that are, or sensors that are put on the doors of these buses again, for example, where you can know See, what here you need is not just people boarding and alighting, you may also want to know once they have boarded, where are they alighting, right? If you want to know that the OD data of the people traveling from this point to this point, not only do you have to have a count of the people that are boarding the bus or alighting the bus, but you also want to somehow know that this is the person that has boarded at this location and the same person exited at this location. So, you know kind of a OD pattern. Obviously, it will not track you, it will somehow anonymize your personal identity, but it will develop a signal saying that this is the same person that boarded at point A and now he or she is alighting at point B. Okay. Again, fuel usage rate, these are very common nowadays in many of the vehicles that are there. It can tell you that your petrol tank is going to run out in the next 200 kilometers, next 100 kilometers, next 30 kilometers. So, all the rates, they are all inbuilt in your vehicles. There are a lot of sensors that can monitor this. All of the newer vehicles have that. Technical status, like I said again, it can tell you whether your car tires are properly inflated or not, whether your transmission is working properly or not. So, all this information via sensors is available in many of the cars currently. Obviously, they will become cheaper and all models of the car will get it. Usually, you will see that the top model of the car has all of these things, whereas the base model will never have these things. But slowly, even we started out saying that seat belts were not required for the base model, but now seat belts are mandatory for all models. So, eventually all these systems will become, once they get cheaper, like always IT systems get cheaper and only then they start getting inbuilt into all different kinds of models. So, once they get cheaper, you will see it for all models as well. The next interesting thing that we are noticing is there are systems available that can monitor the driver themselves. So, now whether you are dozing at the wheel or when you are you alert enough on the wheel. This is something which is very heavily being used for the trucking industry, because the truck drivers drive continuously during the day or the night times. Their hours are heavily monitored nowadays for safety, because they should not get into an accident, and B, because they are almost invariably always carrying goods that are very time sensitive. They are carrying vegetables, fresh vegetables or whatever it is, or maybe not so much when they are carrying bulk coal or anything like that, but many times nowadays in Amazon and everything, they tell you that the next thing is coming in 24 hours. Your item is being delivered in 24 hours. So, just in time delivery. So, if they want to ensure just in time delivery, you also have to ensure that these drivers are alert and they are driving all the time. So, there are facial recognition systems that allow you to detect whether your eyelids are have a certain pattern of movement which tells you that you are alert, or if you are dozing off, it will be able to detect that and give you an alert there itself in your console, or also it can do is it can send an alert to your trucking company, and the company person can call you on your mobile or do something which makes you alert. So, there are these things. The other thing that is there which gives you alerts are, if there are sensors on your car, say your car has a proximity sensor, I think they call it, and the next car also has a proximity sensor. So, if these two cars are running side by side and are coming too close to each other, which means maybe one of the drivers is dozing off. So, lateral separation is reducing, then alerts go off in both of the cars saying that you are too close to each other, or there is alert, there is danger, alert, there is danger. Usually you will see these, I do not know if we have already seen it in India or not, but some of the cars have in your side rear view mirrors, you have those blinkers that blink if you turn left or if you turn right. So, along with those blinkers, they have something called these sensors, proximity sensors. So, that will go red if it can suddenly detect something which is too close, a vehicle that is too close which is not supposed to be too close. So, there is some lateral separation that it will allow, but something it will not allow. So, imagine in an Indian case, if you are driving in a congested city, it may be on all the time because there is some bicycle person or somebody right next to you, but it may not detect bicycle because it will have to detect a vehicle that also has that sensor. So, it has to be a two-way communication to kind of detect this thing. One-way communication will not allow you to do it. So, these things are some of the examples of driver monitoring that are also coming up. Okay, electronic torque correction, I think we have learnt about this in the morning. We are now going to progress more and more towards barrier free toll collection. Now that we have a barrier in the toll gates, the developed countries have moved away from this and they have barrier free toll collection where you can just drive at your own speed, the speed at which you are driving. There are no toll gates, there is only a toll bar or something like that, on top of which it can detect your car at the speed that you are going and do the transaction. So, there is no delay at all at the toll booths. So, we will eventually slowly move to that system, but currently we are at a semi automatic kind of a system where some of us have these what are the easy passes, or what are they calling it, I forget, something which automatically detects your vehicle because of the transponder is there. But then eventually we will have lanes that are dedicated for these vehicles. So, you do not have to go at the manual lanes, you have dedicated lanes for this, and then eventually we will go to barrier free toll collection eventually. Okay. Traveler information display, this is another thing that is an application of ITS in transport. When you are essential, this is becomes very essential when you are new to a city or new to a place. You do not know which line to take. So, this information is almost being now currently displayed on your phones, right. So, here is a picture which shows that this kind of display is there at a station, physical display, which may also be there, but now it is already coming on your phones. So, you are in a new city, you do not know which bus to take to go to your destination, you have apps that will allow you to give that information, right. Surveillance equipment, we all know about the traffic cameras that are out there. Now, majority of the metropolitan cities have speed cameras, right. So, if there will be an automatic challan coming to your home, you do not even, the police is not going to stop you or anything. These cameras are there, the cameras have detected your license plate number. Your license plate number is associated to an address and you are going to get the challan automatically to your address with the speed, with the time at which you are driving. Okay. So, many of the, I think at least the big 4 or 5 metropolitan cities have this already. So, you have to be very careful when you are driving in those streets. They will tell you, I mean, you can see those signs and you can understand that those are speed cameras. So, you have to be, but again, do not be careful just to beat the system. Okay. So, many people are careful just when the police is standing there or just when the camera is coming, and afterwards, chalo phir se. will go. So, do not be like that. This is to change your behavior. So, essentially these things are enabling you to change your behavior, drive safely on the road. Okay? So, because what happens is if you keep, you may say that it is 200 rupees challan and I will keep on paying it, but multiple offenders at one point in time can also be stricken off their driver's license. So, you may lose your driver's license at some point in time if you accumulate too many challans. Okay, so, those systems. So, these are not to beat the system, these are to make you a safe driver. Okay, wearing a helmet only when the police is there, or only. So, back a couple 1 year back, I think the West Bengal petrol stations said that you cannot get free petrol, not free petrol, you cannot get petrol unless you wear a helmet. So, people were just wearing the helmet to take the petrol, and once they finish taking the petrol, they were removing their helmet. So, it is not just to beat the system that you have to do this, it is to inculcate a behavioral change in you. Okay. Then the more advanced technologies is vehicle identification, which I think we got a little bit of knowledge from Professor Shimizu when he talked about the probe devices that are used to detect the vehicles. So, this is more automatic. There are signals coming out of your car. So, maybe direct GPS signals coming out of your car, which is being identified either by GPS or by triangulation of telecommunication towers. They are tracking the movement of your device, of your car. Okay. Plate recognition. So, all of these things allows you to identify the vehicle, not just identify the exact vehicle, not just a vehicle that is moving from point A to point B. And this is the latest, the use of communications not only between the two cars. So, you see these two dots, but also it will be between the car and the roadside device. Okay. So, as we are moving towards automated vehicles, okay, autonomous vehicles, what happens is communication becomes a very key element. Otherwise, you cannot give up your wheel and say that the vehicle drives on itself. So, autonomous vehicles is driverless vehicle on the road. So, how can a vehicle go driverless? The vehicle can go driverless only if it is somehow communicating with the vehicle around it and also with the roadside device that is next to it, and it has to be sort of two-way communication. It cannot only transmit a signal, it has to receive some feedback from the roadside device also. Okay. So, some form of this is available in the traffic signals currently. Some of the traffic signals in some of the cities, in some stretches in those cities, are coordinated. So, if you have heard of coordinated traffic signals, it is not just that one isolated signal is automated, that several of our cities have it. Coordinated signals are, if the road is such that it is almost a straight line and it is almost in a grid pattern. So, what you can do is the signals, the previous signal can talk to the signal in front of it, saying that I am turning green now, and during this green time there are n number of vehicles that are waiting to go away from here, to move from this intersection. So, they will all arrive at your location. So, the next signal's location is maybe 500 meters away. So, they will arrive at your location, which is 500 meters away, within 20 seconds. So, you should also turn green before they arrive. So, these coordinated signals are talking to, they are not only detecting these vehicles, but they are talking to each other also, and hence a driver where you are driving, you get green every time you reach every signal. So, your journey, the delay at these signals is minimized. So, you can coordinate the signals at different locations when there is communication between traffic signals. Okay. So, that is one example which I think Delhi has a stretch that has it, but it has to be a very linear stretch and the junctions have to be very kind of divided at equal distances for all this to work. The volume of traffic also has to be very coordinated. So, it is not easy to develop this kind of a system. I think there was one more. No? Okay. So, I think those are some of the major examples that we wanted to give you. Now, what I will do is, I will give you, before we get into specific case studies of this, I will give you an overview of 152, right. So, I will give you an overview of what is called an ITS architecture. So, now you have these 8 or 9 different systems. So, we just looked at 8 different systems. So, if you wanted to be a system architect, if you want to design these systems, now I want to design a electronic toll collection system. What are the different elements of a toll collection system that I should be aware of, which will help me in developing this system? So, what this ITS architecture does is it allows you at a basic level to identify all the objects, okay, all the physical objects, all the functional objects and all the information flows, right. Communication, as I was saying, communication has to be two-way, has to be between vehicles, has to be between the vehicle and the roadside device. So, there are different forms of communication. Should it be wireless communication? Some cases there are some wired communication. Should it be on Bluetooth? Should it be on Wi-Fi, local network, internet? So, you have to, as a system architect, you have to know all of this because you are developing this entire system. Okay. So, ITS architecture in the in USA, they have built a dictionary. So, this is a form of a dictionary. Okay. They have all these systems that they could think of where ICT is being used in transportation, and they have developed a dictionary saying if you want to build this, these are all the systems that you need. If you want to build this kind of system, these are all. So, once you are aware and you know how to use this dictionary, what you can develop is, if you want to develop something which is not there in the dictionary, then you can use different pieces from here and build your own architecture. Okay. Let us go slowly, you just look into what are the basic elements. What this architecture says is, you can look at the architecture either from a point of view of different stakeholders, or you can look at it from the point of view of the various service packages that are out there. The service packages means these packages such as electronic toll collection, automated vehicle detection, signal system. So, these are all different service packages. These are services that are being provided. You either look at it from that point of view or you look at it from the point of view of different stakeholders. So, what it says is, if you are looking at it from the point of view of different stakeholders, you have to be aware that there are administrators who are involved in this. So, what is the role of the administrator in all of these things? So, you are building a system. Who all are the administrators? There should be traffic people involved in this. There should be maybe IT people definitely involved in this. There should be maybe some cases enforcement people involved in this. So, who are all the different people who will be involved in this and what is their role in developing this architecture? So, that is what the enterprise view tells you. The functional view tells you what user functions are needed. Okay, users, what is the needs of the users? How do the users look at it when they are using a system, when they are using electronic toll collection system, or when they are using this? So, it is a point of view of the users. Okay. Then the physical view is, it will tell you, like I said in the first one, it will tell you all the devices that should be there, what is the communication between these devices, how do they function, everything. And then finally, the communication view will tell you, this is the base view. Okay. This is almost you can look at it up from, if you look at it from ground level. So, this is the first view that you should be all worried about, because everybody, all of the systems have these communication layers in them. So, communication is not only two-way, it can be encrypted communication. So, the communication that goes for the financial to the banks for electronic toll collection, your bank data should be will be encrypted. There is no way that that data can leak. So, how is that data communicated versus the data of position of your vehicle? So, all those data, whether it is two-way, whether it is one-way, all of that is outlined in this communication view. Okay. I know this is if you are not an electronics, if you are not systems engineer, it is difficult to digest in the first go, but try to visualize, try to look at this as a dictionary. These has various tools in it, and you have to use these tools to develop the architecture of your system. Architecture in simple words, in English words, whatever the architecture means, this also means the same. So, you have to have a structure to it, you have to have the different elements in it, you have to know the communications and for what purpose this is being used. Okay. So, what we will do is, there are, so this is a simple example. Okay. This is a view of this is a physical view of a system. So, I do not know what system we are talking about.
Traffic surveillance.
Oh, traffic surveillance system. Okay. So, traffic surveillance system may be a camera at an intersection. Okay. For a camera at an intersection, to develop that system, you need to know that that system has to detect a vehicle. So, in order for it to detect a vehicle, the vehicle has to have something, some kind of communication going between the vehicle and the roadside equipment. So, these are roadway equipment, and they are also color coded for you to understand that which is a vehicle equipment, in vehicle equipment, which is a roadside equipment, and which is a traffic management center. So, this traffic management center has these huge centers with TV screens everywhere, and people are looking at these TV screens to detect any problems. So, you must have seen pictures of these traffic management centers. Many of these big cities have these traffic management centers. So, in order to build this system, you need devices at 3 different places: in the vehicle, at roadway, and in the traffic management center. So, what are the devices you need there? So, here you will need devices that monitor the passive roadway. So, these are functional objects. The bigger ones are physical objects, whereas the white ones inside are functional objects. So, they provide what kind of function should these physical objects provide is written in here. Okay. So, basic surveillance, passive monitoring. So, passive monitoring means it also has to monitor the situation when there is nothing happening. So, maybe the roadway condition, something it is monitoring the roadway condition, the weather condition, it is monitoring passive. Okay. Then there has to be, you have to know what communications have to happen. So, see, this is a arrow going from here to here only one way. So, there is only a one way communication between the vehicle and the roadside equipment. The roadside equipment is not talking back. So, I do not know if there is two way communication. So, this is kind of a two way communication between these two agencies. So, all of this has to be outlined for you to build a traffic surveillance system. So, if your agency wants you, so you are working for a traffic government company in your municipality or wherever, they want you to develop a traffic surveillance system. So, the first thing you should know is what are the components needed in the traffic surveillance system. Once you know all this, then you can go deeper and see, okay, what kind of, so we need this kind of communication, who are the players, who are the vendors that can provide this kind of communication system. Okay, once you know the basics, then you can go out and look for the vendor who can provide me this sort of roadside equipment. What are the specifications, what are the, so then you can get into detail and build this system by yourself. Okay. So, as you are, so now you are converting, now you are becoming from a transportation person a little bit of a systems engineer or a almost an electronic system, mostly systems engineer. If you want to become an electronics, then you have to really know how all these devices work. So, you are becoming a systems architect. Usually the job positions are called system architects. So, you will have those positions if you are looking for. So, okay. So, this is a very high level introduction to ITS architecture. So, what I will next ask one of our research scholars Ishan to do is give you some in-depth case studies that are present in India mostly, India and abroad also, that will tell you how these function, and also get into a little bit of detail of this ITS architecture, so that once you come in the afternoon when you are going to expose you to that software, so you know how to build a system architecture using the dictionary in here. Okay? All right. Ishan, you can now come and take over. You have to be very adept at using this system. Okay. Pointing.
So, Professor Goswami has already given us a very nice and crisp introduction to both architecture as well as how we can implement ICT in intelligent transportation system. So, we are a little bit running out of time, just 10 minutes we have. So, I will go a little faster and will touch the major points. So, we can come back later at these points, we can just note it down in the next afternoon session. We can come back because we will practice some architecture. So, if you have any queries or how these things are happening, you can do that. So, he has already given examples of different techniques or different tools that has been used in ITS. So, basically I will be discussing first about different domains. So, starting with this operation management. So, how ICT is used is to find the actual location as well as the event analysis. Another is to aid the driver. He has already talked about how different systems within a car or within a vehicle is used. So, that can be helpful for a driver. Third was intelligent fare collection system, traveler information, traffic management. Traffic surveillance is a small part within this traffic management system. And this one is the security, like CCTV cameras, which can be not only used for detecting the vehicles, it can also be used to stop different incidents. Like we have already faced some incidents like suicides, metro rails, which actually jeopardize the whole system for one day. So, if you have those video analytics or image processing techniques that can identify that a particular person is crossing that kind of barrier or that kind of limit, so it can actually give the information to the traffic management center, and then adequate steps can be taken. So, these are demand response system. This is mainly for like paratransit service. For us, we understand paratransit means this auto rickshaws and all, but if inverse the context, pattern service like ambulances or the demand responsive services. So, this can also be used, this ICT techniques for pattern services. So we have given some case studies. So we'll start from Indian perspectives and we also some world perspectives. So we can, it's basically to sensitize you guys, so how these things are different, how they approach. Yesterday Shimizu was saying that in Japan it has happened over last 50 or 60 years. But India or in other Asian countries is actually galloping. In last 20 years, there's almost in a fast forward mode. So when you do it in a fast forward mode, you have to tackle or you have to take care of certain situations. So what are those situations? So we'll having this 5 or 6 types of situations where I've given one case study each. So starting with the example of BRTS Indo, that is AVLS and PIS, the simple as automatic vehicle location system and passenger information system that has been used for BRTS Indore as well as other BRTS obviously in Ahmedabad also, which actually influences the customer ratings. So it helps customer and also helps to have better revenue earning services for this BRTS. Next one is the fuel monitoring data, because in some cases in Asian countries or other countries also, there is reports of stealing these fuels or not using it properly. So we can actually monitor. So it can be a fault for the particular person or it can be some mechanical fault also. So you can, over the whole journey of that particular vehicle, you can understand at which point or due to which reason this particular thing is happening. So I can give you the example. Say if you are planning a bus route through a particular congested network. So if you do the whole fuel monitoring analysis for this whole network, you understand that this particular stretch due to this over congestion is actually consuming more fuel. So then you can have some alternative network or you can try some other congestion removing measures. So actually you have to understand all these facilities in ICT is not a planning policy, it's actually tool for you to make policies. Third one is scheduling driver and conductor duties. There are reports that these duties, when these are manually distributed, they don't do it properly. There are like reports for favoritism and other complaints are there. So they uses this kind of automatic scheduling on driver. So properly it's distributed, and we also learn the driver detection, like whether they're alert on wheels or not. So this can be best utilized for that respect. This is signal priority for buses, which has been best utilized almost on every BRT corridor across the world to have this transit priority for buses, which actually makes it a more viable option for to use public transits. One is the same kind of AVLS and FCS integration to Ahmedabad BRTS, that's the fare integration and vehicle location. Now we come back to the world perspective case studies. You can find, if you just follow the track record of how this has been implemented, this also started around 80s to 90s, and they have gradually implemented from electronic ticket machines to integrated ticketing, smart card system. So this you have to follow. I mean, the major aim is to how they have implemented step by step. Now it is not a fault for us that we are galloping, but we have to keep in mind their track or how they have implemented, so that we can make it more sensitive to our cases, like in Indian scenario and other scenarios, and we can implement those particular measures. Next one is for Zurich, Switzerland. They have also that modal share for public transport has been increased through these measures. Third one is Johannesburg, South Africa. And the last case study I have given to one country, that's Ghana, which has more socioeconomic scenarios similar to India and maybe somewhat poor GDP than India. So you can find they have emphasized more on managing vehicle throughputs, managing passenger throughput at stops, managing timekeeping. You can find basically this kind of approach actually varies country to country, and what it says that when you start planning or making policies, you have to keep in mind for which scenario you are making. If you are making for India, then you have to be, your policies has to be whatever policy like ICT, ITS or any general transport policies, it has to be context specific, which will cater to that particular area. Now we started architecture. Sir has already given a nice introduction, so I just elaborate this particular graph a bit more. So basic vehicle means it's just a complete vehicle, like operation, it can be bus, truck or anything. So ITS roadway equipment is the roadway equipment for which you are making this architecture. This architecture is for the traffic surveillance. So any traffic surveillance equipment like CCTV cameras, or similar road signs. This can be the automatic road signs. This can be the ITS roadway equipment in this architecture. Other ITS roadway equipment is with which this particular equipment actually interacts. For say, if you have a automatic signaling system, and then you have a ramp metering, like the car will go on a ramp from this automatic left turn, or maybe you have a transit signal priority. After that, you have a ramp, the car will go. Then this particular ITS system will actually interact with that ITS system. That ITS system is a different architecture. But when we draw architecture for a particular ITS system, we have to consider what kind of information flow will be happening from that ITS system to this one. So basic surveillance is done for this traffic surveillance case through traffic images. And what is passive monitoring? Passive monitoring is that how it can be done to detect a particular vehicle. It can be done through Bluetooth sensor, it can be done through say other modes like license plate monitoring. So it's actually traffic image data is like it's a congregated information, aggregate information. But traffic detector is you are actually finding this particular vehicle, whether it's crossing over these intersections or not, or which intersection is crossing. So it sends the information to traffic management center, which actually causes this kind of traffic surveillance, which also sends the information to traffic information center to store the data, to process it for the future policies, and for immediate actions they send you the traffic operation personnel, who actually determines whether I'll give the transit signal priority at that moment or whether this kind of priority is needed. So they actually determines the traffic signaling system for it. So as sir described this particular thing of enterprise view, this has 4 sections: needs, stakeholders, roles and relationships. Like we can easily understand, first we have to have what is the overarching aim for this ITS architecture, then you must have who are the stakeholders in it, then what is the roles of this particular and relationships in between. So these are the examples, I am just keeping for time being these ones. Functional view means what the requirements, what will be the processes and what is the data flow between each of these items. Physical views means physical objects like your camera, your detectors and all functional objects, and what will be the information flow between them. Communication means standards, profiles and solutions. Standards means under which kind of security or agreement this kind of information flow will be happening. Profile is lower than the standards, like development of solutions through ArcIT. We'll later understand in the afternoon session. RAD-IT is like building the overall architecture for this whole area, and solutions is collection of the protocols under which information flow can be happening. So these are the, if you just broadly divide, this is like field equipment from which we get the information to the support system and centers, and information is collected through the traveler devices and vehicles. So these are the all the service packages. I have given couple of examples within under each of the domains. You have in total 24 service packages under ITS architecture that has been prepared by US Department of Transportation. So these are just some examples, and under which I am given 1 or 2. You can, if you just go to their website, you can get lot others within which. And this is another example of connected vehicle traffic signal system. So one of the main thing to understand is how the information flow will be happening to each of these stakeholders within architecture. So within flow, 2 contexts is there. First one is that you have to understand the flow cardinality, security and control, like from whom to whom the information flow will be happening, whether these are unidirectional flow or multidirectional flow, or whether the information has been acknowledged by the other one or not. And other things, the flow time context and spatial context, where the flow is going and whether this kind of information, the reaction is happening right now. For example, what I said, the traffic operation person has to react then only when you are getting the information about a particular ramp or traffic signal system. He has to react immediately to give, okay, we can have a 30 seconds green cycle for the vehicle. But for the traffic management center, you are actually storing the data to analyze it in future to have all these pollution measures. So that's how you have to know what kind of information you have to collect and how will you use it in this architecture. So challenges with respect to world is the usability of the data. enforcement of the extracted information, like you can collect lot of data, but how you are going to analyze that, it's a quite important aspect, and awareness for it. Like you have to sensitize people that what will happen with this data, because as Shimizu was also saying, we can collect lot of data, big data from your phones or something, but if you don't make people understand that how you're going to use it, how it's going to benefit them, they are not much interested to use it or bit care about that. Also, Professor Goswami was saying that there are like serial offenders, but that is also a partly a fault of the administrative system, because you can't sensitize the people what is there for their benefit. So you have to take care of that to make it successful. For India, it's like integration of ITS. It's not totally integrated till now. So as I already said quite a lot of times, like it has to be context specific. Lack of definite guidelines. We need some proper guidelines how to implement ITS. Cost is always an issue, and you have to have a nationwide system. Like now, just a few days back, our Prime Minister announced one card, one nation. So we have to have very careful about the implementation aspect. Like we already had a lot of these things. Like you just overnight you cannot be smart. So you have to be careful about how you implement that, because if you're just using this credit card as a mobility card, then are your security infrastructure is solid enough to give you that much protection that it will not be misused. So you have to take care about that, because if it is misused once, people will actually lose faith on the system, and it will be very hard to regain that faith. And road ahead, it's already has been used by different transportation companies, different government organizations, Ministry of Road Transport and Highways. In fact, I can give you the example I was looking that day. Like Indian Railways are installed some system called B. It's actually lot of accident happens with elephants, because when it's in Jalpaiguri and north part of this West Bengal, different accidents happen. So they have installed this kind of device in the train, in the engine part, which gives certain signals, that like sound waves it makes, which actually the elephants can hear, and they actually stay away from the tracks. So this is also kind of implication of ITS. So you have to be intelligent enough for how you can use it. It has to be environment friendly too. These are the further examples of how different cases has been used for different smart city projects, and mainly it has been still limited within the government initiatives. We haven't still found that how much these private enterprises are into this intelligent transport thing. So these are the resources you can just go through later on to find the more information about how we collected. These are some websites to collect it. As I was saying, the US dot like local ITDs is the US Department of Transportation, where you can get information about the architectures. So that's all. Thank you.
All right. So I know it's a lot of information, but the way GAN is designed is for you to take all this information, go back, and then get more in depth into whichever aspect you are interested in. Right? GAN is only 2 hours and 2 hours, 2 hours in the morning, 2 hours in the afternoon. So it's only so much that can be taught in 4 hours every day. So the whole point is that's why we are giving you all the resources